Okay, follow along on your scratch paper for the Math on the Spot video.
Hey, I was just admiring my beautiful Flags of the World collection. And actually, you see these flags usually in interesting ceremonial moments like parades and things, especially when you see the Olympics and they're all marching, all the athletes with their flags. And hey, actually, that reminds me of an interesting math riddle involving Max, who is actually thinking about the flags involved in an old Olympic Games. Let's take a look at it together and see if we can make sense out of what Max was trying to do. Let's check it out for ourselves. Okay, so Max arranges the flags of the countries in the 1896 Olympics into 2 equal rows. So he wants 2 equal rows. What we want to do is write and solve a multiplication equation to find the number of flags in each row. Well, the first question we have to ask ourselves is, how many countries actually participated in the 1896 Olympics? Well, I don't know off the top of my head, but luckily we have a wonderful chart, that table, a graph, that actually gives us, this graph tells us, in fact, for various years in various locations, the Olympic Games, this represents how many countries were in fact represented. And so, for example, if we look at 1896, we see that that red bar goes up to, this bar graph can be red, it's right between 12 and 16. So what's the number between 12 and 16? Well, it's 14. So we see, in fact, that there are 14 countries that are represented. That means that there are 14 flags that Max has to arrange into 2 equal rows. Okay, so how might we proceed? Well, one thing we might do is, we don't know how many rows we're going to how many flags we're going to have in each row, and so we might actually give that a name. Why don't we call that unknown quantity F for flags? So F is going to represent the number of flags in each of the 2 rows. So if we have 2 rows, and each row will have F, some unknown number of flags, then how many flags will we have altogether? Well, the total of 14. So what does that mean? It means that 2 times that number of flags in each row, we have 2 rows, times the F, must give me 14. And that is the equation. So here's the equation. 2 times F equals 14. So there is the equation that will allow us to figure out the mysterious unknown F, the number of flags in each row, knowing we're going to have 2 rows, and each row we will have F number of flags, and altogether we have 14 flags. Now, how could we actually model this? That's the question. Well, we could actually use algebra tiles. So let me show you how you might model this using algebra tiles. What we might do is we take a frame like this, and what we're going to do is, in fact, I'm going to bring it way down here. In fact, no, you know what I'm going to do? I'm going to keep it right here, and I'm going to, well, check this out. I'm going to move my equation. And now we can see both the equation and the model of the equation at the same time. Isn't that clever? Aren't I clever? I might deserve a gold medal. We'll see. Okay, so what do we want to do? In this box, we're going to represent this side of the equation, and in this box, we're going to represent this side of the equation. Now, this side's very easy. It's just 14 units. So all I need are, in fact, 14 ones, and each little square represents a 1. So, in fact, all I've got to do is bring on 14. So here are the players, and you can count for yourself. In fact, we can see 1, 2, 3, 4. 1, 2, 3. So 4 times 3, there's 12, 13, 14. So there's 14 right here. That's easy. Now, how do we represent this? This is saying we have 2 times the unknown. So remember, we represent the unknown as a kind of weird shaped thing, this rectangle shape. And so now this says we have 2 of them. So actually, I've got 2 of them. And so I have 1 here, and then I have 1 here. So this means 2F equals 14. Now that's where we are right now. And now, where do we go from here? Well, what we have to do is what we want to do is we want to figure out a way of saying, okay, I want to know just what one unknown is. So here I've got, one of these unknowns, and then I've got another unknown. So what I want to do is I want to take this and I want to divide it into two groups. Two equal groups, in fact. So what would the two equal groups be? Well, the two equal groups would be, there are lots of ways of actually grouping them, but one way is to say, okay, I'm going to have 7, group of 7, and then another group of 7. Do you see how I'm grouping things into two equal groups? I have two equal groups here, unknown, unknown, so I have to have two equal groups here, number, number. And how many are there? 1, 2, 3, 4, 5, 6, 7. Let's make sure there's 7 here. 1, 2, 3, 4, 5, 6, 7. Good. Okay, so what does that mean? It means that any one of these circled things must equal any one of the circled things here. Well, that means that f, the unknown, must equal 7. And so what we conclude is that f equals 7. And we can actually check and see if that's really correct. If I let f equal 7, is this going to be a true statement? Is 2 times 7 equal to 14? It sure is. And so that tells me that we actually have the correct answer. So the answer is f equals 7, which means there'd be 7 flags in each row, and that together would give us the 14 flags. So we actually wrote down an equation, and then we actually were able to solve it using algebra tiles to find the solution. And you know what? I think that you and I did so great in actually figuring out an equation and then actually being able to solve the equation that we deserve a gold medal. But since you're not here with me this very second, I will accept the gold medal on behalf of all math students all over the world. And since I actually live in America, I will raise the American flag to represent the mathematics that we've all just enjoyed. So please, right now, let us salute mathematics.
Thanks for watching, and I'll see you on the next one.